Welcome. One of the most common confusions that students end up with when we're talking about functions is the difference between injectivity and being well defined. So I find it worthwhile to spend at least one lecture talking about the difference between them, like comparing them. And then also it's going to take some work on the part of the student to actually look at the definitions and examples and make sure you're keeping it straight. Okay, so people often confuse. So people often confuse So we have injectivity. So F is injective. So here is F is injective. Right. And what does it mean for F to be injective? It means that if I get the same output for two inputs, right? So if F of S1 equals F of S2, then I know that all along I had S1 was the same thing as S2, right? Whereas on what does it mean to be well defined? So this is the first one, and F is well defined. Which actually tells you that if, right, this tells me that if S1 equals S2, then F of S1 equals F of S2. And I think part of why this is confusing is because we don't think of this as being something that we need to check, right? But it's actually going to be something that you're going to need to check, particularly if you're talking about like a function defined on equivalence classes. Or sometimes when you write down, like as an equation, the definition of a function, you don't actually realize that, you know, you're describing the same thing in two different ways, and then you're saying that the outputs for that are different depending on the two ways you described it. So you have to be very careful about this. Actually, a lot of times you will actually need to prove that a function's well defined, but that's not the same thing as injectivity. So what's the difference between? So the difference is right, so for injectivity, right, you have to satisfy the horizontal line test. So it's the horizontal line test for injectivity. So the horizontal, so let's just draw it. So we have, right, this can fail the horizontal line test, so it's the horizontal line test. So injective functions must pass the horizontal line test unlike, right, if I have a function here, and I mean, because what is a horizontal line test really telling you? It's telling me I had this same output for these two distinct inputs, right? I had S1 and I had S2, and precisely where I failed here is where I have that, right, this height F of S1 is equal to this height F of S2, right? Okay, versus, I believe the language should be familiar from earlier in your mathematical expeditions, that you have the vertical line test. Well, let's make this go down a little bit. Okay, so if somebody drew, and this could be a implicitly defined function, but then that's, you know, one of these things, we don't use that as a function. We don't use that language for a function. Let's put versus here. So versus, here we have, this is the kind of fail that we might get. So fail of vertical line test. Right, because here it's like, right, S1 equals S2, but, so this is like S1 equals S2, but maybe then, because of how you describe things, it looks like here, maybe this is the point, it looks like you've got a point here, which is, S1 and then f of S1. And here it would look like you had the point S2, f of S2, but really really these were just two different descriptions for the same thing, and so you shouldn't be getting two different points. Okay, so well defined of, means you must pass the vertical line test. Okay. In particular, so one thing to keep in mind here is that the second one is talking about, this is a requirement for being a function, okay? So this is a requirement for being a function. So we don't, in the way that we talk about things, we don't talk about something as a function that fails to be well defined or fails the vertical line test, right? But you can fail like this is just f of x equals x squared. We're perfectly happy with that. That's a function. We have no problem with that. So you can be a function and fail to be injective. You cannot be a function and fail to be well defined. But this is precisely where students end up getting confused, I think, is that the implications are swapped here, right? So the implications are swapped. Right? In the first case, we're saying that if f of S1 equals f of S2, then S1 equals S2. In the second, we're saying that if S1 equals X2, then f of S1 equals f of S2, and those have two very different meanings. So it's very important to keep those straight. Okay? So I hope this was a little helpful, and just, try to be a bit careful about this, and I will see you in the next lecture.